All right, this week we'll just take a quick introduction to look at how the education system has changed in the last few years to adapt to the idea that there has to be more of a literacy around computer science and just where that originated from, what are some of the pieces that are in place right now to support that in education and where things seem to be heading. So I put a number of different resources in the Google Classroom there. One of them would be just this quick little video is called Code Stars. I mean, it's just more of a marketing campaign to try and promote awareness by using people that are, sort of high profile personalities to try and encourage a generation to take an interest in coding literacy. So that would be worth taking a look at just to sort of see how computer science has become something that is not just I guess it's kind of more mainstream in terms of its approach in education. I think it's also us coming back and just thinking about the idea that coding doesn't have to be complicated. We are looking at sort of encouraging this literacy starting in grade primary, and a lot of it's not coming down to the idea. It's not coming down to the idea that we have to create computer scientists, that we have to create people that have in-depth knowledge around how to generate code, but an understanding of how technology is constructed. So much of what we do now is digital, and so it's more about the idea of moving from consuming to producing information. And much like we've done with media in the past, we are always encouraging kids to be media literate, which encourage them to be creative using media as opposed to passive consumers. And I think we would say the same about coding literacy or computer science literacy, however you want to put that. It would be the same ideas that we want to encourage them to be critical thinkers around the use of technology, how technology is constructed from that perspective. So it's not necessary to be have an in-depth knowledge, but at least a not working knowledge. So no matter what you do in terms of a career, or no matter what you do in terms of your role in society, you understand how coding is sort of a foundation of a lot of the tools and a lot of the services that we rely on. So, we've seen that sort of progression. And again, I'll go back, it's similar to media. Even though there's a time that when we wanted to create video in class, it used to be quite an ordeal, and it would take a very specialized piece of technology and to actually have the software for, oops, sorry, and to have the software for students to be able to do that in the hardware and all that. So now it's the same. I think coding's become more attainable because we have things like block coding, and we have games, and we have devices and hardware that can teach the concepts of coding and computer science at an early age by putting these tools in the hands of students in a way that was never available before. So instead of sitting in there and manually typing out lines and lines of code, there's this it creates shortcuts, and obviously it's limited in its scope, but it also is teaching them sort of the understanding loops and algorithms and logic, and it helps a lot to connect to curriculum as well. So showing them, how does this now connect to digital storytelling, or how does this relate to math concepts, or how does it relate to science, for example. So there's a lot of connection there to curriculum as well. So it's, we do have to sort of think about it more of a problem solving approach. So we'll talk sort of like computational thinking, using the idea of what technology can do and how we use code to solve problems, and how we, it's teaching kids to think like technology, or think like a computer would think to solve a problem. And so, we kind of see it as that. And I always use the example of, and you've probably seen, that app, if this, then that. It really is that simple. It's just trying to think of, to have a desired output, what are the inputs that I have to have? And so starting off that simple concept, and as kids build their skills in computer science and coding, then obviously the problems and the solutions become more complex. So we're also starting to see, of course, too, the type of devices, the physical devices. So linking coding and computer science to physical devices, which again, I think the changes in technology has made it really easy for students at a young age to actually see that they can, sort of take their problem solving skills around coding or their creations in coding and apply them to a physical object. So whether it's robotics or electronics, you look on the screen here, and we've always had sort of the Lego League type robotic challenges, which have been going on for years and years. But we're starting to also see things like Little Bits, which are these magnetic circuits that you can snap together, which basically are input output, has a series of sensors or buttons for inputs, and the outputs can be everything from power, motors, speakers, and so kids can actually take that concept. And as I always tell the story about this little primary kid who created a fart machine in 5 minutes, was able to do that, which the idea of a primary student creating a machine and then eventually even learning to understand how to code to make that input output even more complex certainly is something that our students are dealing with. So I think it matters because a lot of course, our society is now based on this whole Internet of Things. Everything's connected. Everything's based on that relationship and the glue of coding to keep everything together. Again, I think it's important, no matter what you do as a career or what your place in society is to have this understanding, because there's more connected devices than people, and that's only going to grow exponentially. So it's important for us to understand the role that plays if we're going to play a role in our society. And I think too, going back to where we are in Nova Scotia, is that I think there's no doubt that we've seen dramatic change in society, but small rural province like Nova Scotia, where we've had more of a traditional economy, we have to figure out what's our place in the world and how are we going to overcome some of the challenges of aging demographics and industries that aren't as profitable as they once were, and a shift in our workforce. So the Ivany report from a few years ago looked at what are the challenges and what are possible solutions, and one of those possible solutions was the information communication technology industry, and how Nova Scotia could become more innovative in terms of encouraging entrepreneurship in this area, encouraging the growth of the business. And we're seeing now, I think we can see examples now of small businesses growing up in small town Nova Scotia, because in a knowledge economy or an ICT industry, we know that you don't have to be in New York City or you don't have to be in Toronto to be successful. That we have people that are being successful in their hometowns or in small town Nova Scotia. So we see these high tech companies starting to pop up across the province, and so I think that's where of course, it's also, and I did put a section of the report in there to talk about sort of, you might want to take a look at, just to talk about where we are in Nova Scotia in terms of our ICT sector and some of the potential that's there. But of course, in order to reach that potential, it's important for us to also prepare our students for that. So part of that, I think, came directly from the Ivany report, would be the idea that we have to reimagine our education system. So the education plan, that's sort of changed our curriculum and changed our approach. A lot of it, one of the pillars of it was to have an innovative curriculum, and a lot of that was technology. So providing students with the basics of coding, technology, and design thinking, which again, that's where we've seen a lot of influx of, in the curriculum. We have coding outcomes now that are integrated in our ICT outcomes. There's a coding strategy. They started a TAP program, which is a Technology Advantage program, which is kind of like a technology-focused co-op, and they tried that in a few schools where students would go in and they would be, put into. They take the courses, of course, around technology that are available, but they'd also be in the field working at businesses, and they would have a spot at NSCC or university to expand their post-secondary use of technology integration and coding and computer science. So I think we're starting to see also an influx of, the province has put a lot of things into the classrooms as well. So, you look here, these little robots they've sort of started. Bbots are like basic teaching kids the basics of logic, and at primary, and then they move their way up to the dash robots and spheros, and starting to get into make block type robotics. And so they're progressing through, and they're understanding, and as they go through the grades, it becomes a little bit more complex to the point where they're actually using coding to build more complex machines and more complex solutions and sensors and things like that once they have that potential to reach high school. So we're starting to see now that some of the first, so it's been 5 years, but what we should see coming up through high school is kids that are more computer literate and coding literate. So hopefully that will pay out in the end. There's also the organization called Brilliant Labs, which is funded by the school or the department, and they do a lot to encourage, again, the idea of using technology as a means of problem solving. And they're partly also funded by the ICT sector as well. So trying to create innovative thinkers in our school system that have a knowledge around technology, coding, and using some of the maker technology that would kind of combine the two things. We've had before COVID, we always, every year, we'd have our own conference for middle school and high school students. We called it Avier SB at 21C. Was really trying to encourage kids to think about their future, and to think about integrating ICT technology and entrepreneurship and innovative thinking. So this is just an example of some of the things that they would do. It was all around, they would hear from people that are in the ICT sector in our communities throughout the valley, and then they would also, then we give them a modern world problem challenge, a lot of it from the Ivany report actually, and they would, in groups, they'd have to collaborate and be creative, and a lot of the times it was based on coming up with a solution to the problem, and 90% of the time it was technology based. And so they saw the potential of what they're learning in school and why it was important to have that literacy. So that's where you're combining this whole idea of real world learning, tackling challenges that exist in society, and then applying the problem solving cycle or design thinking cycle, or incorporating inquiry, which is a big part of our curriculum now. And I think the glue between those things is, of course, technology, and coding and computer science. I think is one of those things that is something that all students should have a knowledge around, because it is going to be the one thing that can be used to solve complex problems.